Now, it gives me pleasure to announce the first presentation for today. Mr. Viacheslav Ermakov from VNIIEM Corporation, Russia, will tell you about high-resolution microsatellite. Hello, distinguished colleagues. First of all, I'd like to thank the organizers of this conference for the invitation, for the opportunity to speak about our company, about our plans and projects. Our company is called a joint stock company, production corporation of space systems and monitoring, of information management and electromechanical complex, and the abbreviation is SA Corporation of VNIIEM. This company is one of the oldest companies, which is part of the structure of Roscosmos, and it was established in autumn 1991, and it was established for the development and production of electrical technical facilities, and then we were converted into a research institute. This brief history of our company can be seen on this screen. In the very first years of space exploration, when our country was making first tentative steps, VNIIEM, as the chief organization, actively participated in the development of electrotechnical equipment for the rockets. For instance, we participated in the development of the famous rocket R7, which was used to launch the first artificial satellite of Earth and then the first piloted spacecraft Vostok. Owing to that success, our VNIIEM had to build first meteorological satellites. First such satellite, Cosmos 122, was developed by our company and launched to the orbit in June 1966 and 1967. Two more meteorological satellites were launched, Cosmos 156, and in this manner we prepared the first unprecedented meteorological system in the world, which, as you can see on the schematic, was used successfully for a number of years and was replenished by similar spacecraft or satellites with improved characteristics and new set of payload. In the past few years, we have accumulated wealth of experience in developing and launching new satellites. We have launched a total of more than 85 satellites. The overall flight time of all our satellites amounts to more than 210 years. On this slide, you can see our satellite Meteor M2, which is at the moment on the orbit. It was launched a bit more than a year ago. It is a meteorological satellite, and it is equipped with full complex of meteorological and scientific and research equipment, and it is designed to acquire information about global and local cloudiness, snow cover in visible infrared and shortwave bands. It helps acquire information about the temperature of marine water and the information about ozone layer and heliophysical information, and a whole complex of additional information that help us better forecast weather. On this slide, you can see a satellite. To your left, it is, you can see the satellite at one of the assembling stages. On the right, you can see a completely packaged satellite before taking it to Baikonur. It was repeatedly mentioned here, Canopus V, and our company is not participating at this conference for the first time. In previous Rakurs conferences and maybe in subsequent presentations, you will hear more about how to use materials acquired by Canopus V. My colleagues will tell you more about it. I just wanted to note that the principal tasks that can be performed by the Canopus V would include mapping, land use, monitoring, agricultural assignments, natural resources, technogenic, and disaster management. Like, for instance, it was mentioned, I think 2 years ago, when we had a catastrophic flood on the far east of Russia. The materials acquired by our Canopus V satellite were actively used both by the Ministry of Emergency Management of Russia and Rosgidromet, and they were highly appreciated in terms of their quality and in their capacity to forecast disasters and emergencies. Here on this slide, you can see the launch-ready rocket, and then the testing on the testing mount in Baikonur. You can see the satellite before we put the cowling over it. So these are two twins, brothers. To the left is Canopus V, and to your right is Belarusian Satellite. I will tell you more about it a bit later. I will tell you more about Belarusian Satellite. You are aware of its characteristics already. They were mentioned previously. There are two cameras, panchromatic cameras mounted on it, and they also have multispectral bands. And the swath up to 33 kilometers. And the precision of geo-referencing using orbital data is 30-50 meters. And these satellites have been in use for 2 years already. So they were not only tested in real operation, and the accuracy proves to be higher at 4-7 meters. Another thing to note is that this satellite was developed and built in a small form, lightweight. The overall weight is 470 kilos. Perhaps it's unprecedented for Russia when we built a small remote sensing satellite with such specifications. Capacity-wise, this satellite can acquire up to 1 million square kilometers per day, which has been confirmed by the successful operation of this satellite in the past few years. Here you can see the satellite orientation during the orbit of flight. And on the left part of the slide, you can see the satellite in MIG in the final testing mount at the final stage of the assembly. At the same time, we developed and launched a Belarusian satellite. The work was done based on the contract signed with the National Academy of Sciences of Belarus. Simultaneously with this satellite, we developed and supplied the ground segment, which includes the ground flight management complex and information reception and processing complex. We trained specialists in Belarus, and now our Belarusian colleagues are successfully operating this satellite. Our company is actively cooperating with different universities and institutions upon the request from the Moscow State University. Now we have already built a new satellite called Mikhailo Lomonosov, dedicated to the memory of the great Russian scientist, the forefather of Moscow State University. This satellite will be used for different scientific experiments and research, mostly to study different phenomena in the upper strata of atmosphere.
Тоже один из примеров.
Lomonosov satellite will be the first satellite to be launched from our new cosmodrome Vostochny. So as soon as the cosmodrome is ready, I'm sure successful launches will follow. This is another example of good cooperation with Moscow State University. This is a small size satellite called Tatiana, named after the student day or Tatiana's Day. There is this holiday in Russia. It weighs only 70 kilograms. It was designed and assembled by students of Moscow State University in terms of equipment. And in terms of the platform, another youth team was put together which did the project. So the satellite was successfully launched in 2009, and it performed all the tasks attributed to it. My company is engaged not only in design and development of satellites. We are multitasking enterprise, and one of the areas that we cover is development of various electrical and mechanical systems, such as flywheels, motors, antenna feeder devices. All of these devices are designed and installed on our in-house satellites, as well as satellites manufactured by other enterprises under the Federal Space Agency. We're also a world leader in designing, creating, and implementing a nuclear reactor physical protection systems. We have been doing this for over 50 years. We're the top leader. Our posters and stands, our stands are installed in a vast majority of stations around the world. You can see some of the text has been translated into English. We're also one of the best in creating magnified, enhanced electromagnetic ball bearings. How does it work? The rotor is hanging in a field, in a magnetic field. It does not require lubrication. It's like a perpetuum mobile. And the capacity of such units may reach 50 megawatts. It is used by Gazprom actively to pump gas, to provide the required level of pressure in pipelines. Also, another area we do is designing electrical engines, power supply systems for ship navigation. We pay a great deal of attention to quality of the product. We've developed a quality assurance policy. The key objective here is to ensure quality at all stages, from designing to production. We are a testing facility. There is a couple of slides here about our production capabilities. This is our assembly and testing facility, a big room to assemble large satellites like Meteor. You see the people, how small they are next to the satellites. And this is how Belarus satellite is being put together. This is the actual size. This is VNIIEM satellite at one of the final stages before being transported to Baikonur. There's a large echo-free chamber where satellites are put inside to check their electromagnetic compatibility. Indeed, this is a huge chamber. Meteor satellite is big and heavyweight, but it looks here like something very small. Various rigs for climate testing, rigs for mechanical testing, thermal vacuum chamber, where satellites are put inside and the chambers recreate the open space, ensuring temperature differences reaching hundreds of degrees on different sites. This is nuclear reactor testing rigs, various assembly testing, harvesting. We are actively engaged in international cooperation in a range of fields. So we used to say that we operate for companies from Gazprom to space. So all of these things are covered by our enterprise. Why did we decide to familiarize our colleagues with our enterprise in greater detail? This is not the first time we participate in the conference, and it seems to us that it would be deemed appropriate and expedient for software developers to know more or have deeper knowledge about satellite designers, because at the designing stage of a satellite or its components, we are fully aware that what we do is evaluated vis-a-vis the imagery that our satellites are able to capture and acquire. So maybe at this very stage, designing and development, we need to have more cooperation with our distinguished colleagues. There is one thing I overlooked. When I talked about Canopus and Belarusian Satellite, which will soon celebrate 3 years in orbit, I wanted to add that these satellites have now been separated in one plane. They created a space system operating for the benefit of two countries. In the next 3 years, 5 more satellites will be orbited. Canopus V with similar specifications, or maybe even greater specifications. We are looking into how those specs can be enhanced. So in the next 2 to 3 years, there'll be a constellation of 6 satellites of Canopus V standard, which creates a situation on the Russian market of remote sensing where there will be a lot of similar information ranging from 3 to 5 million square kilometers of daily acquisition, which will require development and optimization of data processing tools. If I'm not mistaken, Rakrus has been the first company to support processing of data from Canopus. In the light of coming changes, maybe we need to cooperate even more closely. Now about the small size, high resolution satellite. Yesterday, in a number of presentations, we heard a request, a demand to continually update data, remote sensing data. This data needs to be fresh, needs to be fast, and easily to access. So based on our successful experience with Canopus, we now seek to design small satellites further. There is a number of options at the company, which are now in various development stages. So one of such options that we would like to offer for your consideration is this. Well, but let me finish first. Since our policy has now shifted towards small satellites, and when we select masses and weights, we are looking to be able to have cluster launches. This saves money tremendously. I mean, launch cost is brought down significantly. Plus, we're able to roll out and deploy a large constellation. One rocket carrier is capable of launching up to 9 satellites. So these are the envisaged specifications. Better than 1 meter resolution, swath width 17 kilometers, viewing swath 500, weight no greater than 250 kilograms, service life up to 7 years. And the dimensions 110, 90 by 90 centimeters. The planned imaging modes will be shown now. Based on the platform experience, based on our experience, the platform should provide the standard route survey, frame surveys, arbitrarily directional survey, reverse imaging, which will allow increasing swath from 17 to up to 50 plus kilometers, stereo imaging in one pass, and various combos of panchromatic and multispectral imaging. Also, with this satellite, we will have created the ground segment to receive and process targeted data. These slides show processing and receiving techniques. They are very familiar to you. The conclusion is, based on the experience and successes that VNIIEM company has, we now seek to design and develop constellations of small size satellites. This project can be implemented in under 2.5 years. Well, that's all I have to say. If you have any questions, please ask. Thank you very much, Vyacheslav Arsentyevich. Indeed, a very interesting report. I'd like to abuse my powers of the moderator and say that we've always striven to support any remote sensing data emerging on the market, and we are willing and ready to cooperate with you even before the satellite is launched. So thank you very much. Do we have any questions from the floor? Victor? I have two small questions. First of all, you said that the constellation will finally be created, but I read in the news that the constellation will be cancelled. This constellation will certainly be created in the next 2 to 3 years. Launches will vary, and I can tell you that in the coming years, 6 satellites will be launched to orbit, and it has nothing to do with the cartograph project, no. I talked to the general director of corporation, and he promised that you use your own money to launch satellites in orbit, create the ground station, and then you provide other services. let me elaborate for just 2 minutes. Yes, of course. Yes, indeed. We do have this type of service. I think in the spring of the last year, VTP24, jointly with leading banks of Central and Southern America, conducted a congress to see and to look for science-intensive projects which banks could fund. We know that this is a very expensive undertaking to launch, design and launch satellites. So we said there that our enterprise is ready at its own expense or by using borrowings in case there is a contract placed with us to create a full orbital segment together with the ground segment and commission it after the satellite has been launched upon verification of all contractual specifications. And only then the contract is closed and we get paid. So this proposition is definitely valid. Any other questions? If there are no further questions, let's have the next presentation. Let's thank Mr. Ermakov.